because you do need practice on this stuff. Okay, in addition, I'm going to be gone tomorrow because I'm going to Math League. I take my students to a Math League competition at MSSU, so I'll be gone in the afternoon with them. So I'm going to be leaving a worksheet that's doing exactly the same thing. So you're going to get, as today's.
Okay.
In fact, we're going to do the same thing on Wednesday as well, because you got to get it up here before we can move on. Okay, yes, what?
What are we doing Thursdays? Kind of might be going Thursday.
Thursday, we are doing verify, which is a little bit different than that, but it's pretty much the same. But that assignment's written there in case you need it. Okay, so are we ready to start with my examples?
Yes.
Okay, I already have the examples written down. So I'm going to start with the first one. Now the key thing on what you're doing on every problem today, every problem tomorrow, every problem Wednesday, is you've got to simplify the trig expression. You try to get it down to where there's just one trig in your answer, or it could be a numerical answer, but it's simplified. So I'm going to start with example 1. Now I'll tell you right now, I have, and there's more than one way to skin a cat. You guys have heard that old saying, right?
No.
There's more than one way to get this done. Your process of doing the problem might not match your neighbor's. In fact, I hope they don't all match.
Shouldn't it be order of operations though?
You still have to follow order of operations, but you may use a different identity to help get where you need to go. You see what I'm saying? Not everybody has to use the same method. To grade these assignments, it takes me more time to grade because everybody can do it differently. Everybody can do it differently. So there's not a set guide. You got to look at it each individually. Okay, so now one thing I always tell, until you get used to doing the 8 identities and to verify and to simplify, get it down to the 2 easiest, sine and cosine. So until you get used to all the identities, you might want to change everything to sines and cosines to make it easier for you. Okay, so if we look at this expression, what could we change secant to?
1 over secant would be cosine.
1 over cosine. What could we change cosecant to? 1 over sine. And tangent.
Sine over cosine.
Sine over cosine? Does everybody agree with that? Now, you still always have to follow the order of operations, so that's correct. So this would be 1 over cosine sine minus sine over cosine. We good so far? When you got to multiply before you can subtract. Now, all the rules that you've used mathematically throughout the years are coming back to haunt you today, because now I'm subtracting fractions. What do I have to do to subtract fractions?
Common denominator.
Common denominator. What would be my common denominator?
Cosine x times sine x.
So this one's good to go, so I'm going to call it 1. What do I got to multiply this by in order to get this? What do I take times cosine to get cosine sine?
Sine x.
Sine. So sine times sine is?
Sine squared x.
Now hopefully on, I think it was Thursday, because it's the last time I saw you guys, I told you there are more than one way to write each of the main Pythagorean ones. I hope you rewrote them so you have those to look at, because they're going to be beneficial. Remember, sine squared plus cosine squared equals 1. Couldn't that be written 1 minus sine squared?
Yeah.
And what does that equal?
Cosine.
Cosine squared. Remember me telling you to write those down. So technically, this is now cosine squared. And now what can I do?
Divide by cosine.
Reduce. So I now have cosine over sine. Which what's cosine over sine?
Cotangent.
Cotangent. What did we just do? We are now finished. We've simplified that original expression down to cotangent. Okay, now, one other thing I might go ahead and discuss with you. I have students that like to do the butterfly method of addition and subtraction. Have you guys heard that before?
No.
Okay, well, this you don't need to write down. It's an option. If I have 1/2 plus 1/3, you guys know in order to add fractions, you have to get a common denominator, right?
Yeah.
Or you can do what's called the butterfly method, which the first wing is 1 times 3, which is 3. The second wing is,
2.
and then you always multiply the numbers in the denominator, so I end up with 5/6.
I like that more.
Okay, do you guys see how that works?
Yeah.
Doesn't that work? Don't we know 1/2 is 3/6 and 1/3 is 2/6, and I add them and I get 5/6? It's
Yeah.
called the butterfly. But the butterfly only works with two fractions. So it also works in subtraction. What if I have 1/5 minus 1/4?
So it'd be
4. The minus goes with the 1, so that'd be a -1 times 5. And on the bottom you've got 20?
Yes, so it'd be, yeah,
-1 over 20? Okay, now, I want to go back to this part. Don't need to write this down again. We did it by the fraction way. Get a common denominator, right? Could I have done the butterfly?
Yes.
It's two fractions, they're in subtraction. So what would be my first wing?
The
Cosine. What would be the second wing? What's the cosine sine times sine?
Cosine squared times cosine.
It'd be cosine times sine squared, right? Because there's two sines. Over the denominator, you gotta multiply, so isn't that cosine squared sine? Now, it creates one more step since we did the butterfly. On top, isn't there something in common?
The cosine.
So we factor out a cosine, which leaves me 1 minus sine squared,
That's cosine.
which is what?
Cosine.
Cosine squared, right? 1 minus sine squared is cosine squared, so I'm changing that. That's gonna become it. Now, doesn't that cancel that?
Yeah.
Don't I get cosine over sine?
Yeah.
So I get the same answer. So I just showed you another way it could have been done. Okay?
Is that shorter than the other way, or is it the same way? The same.
It's a little bit longer, but most of the time it's shorter. Okay, that was example 1. Okay, example 2. And I have how many examples up here? 8? I'd say if you write down 4 today, you're good. I'd like you to just comprehend on some of them, and the others just make sure you get 4 written down. Any of those 8 examples will be good. So we're ready for number 2. Since I don't have that much board space, I have to accommodate that way. Now, what do you notice about this example? Isn't it already in terms of sines and cosines? Isn't that what I recommended for you to do in case you
Yeah.
have trouble? But what do we know about 1 minus cosine squared?
That's
Equals
sine.
Sine squared.
Yeah, sine squared.
So that ends up being sine cosine over sine squared. Now what happens?
You
Can I cancel a sine?
can, yes.
So it'll leave a sine, right? So what do I have left?
Cotangent.
Cotangent. Cosine over sine is cotangent. So example 2's done. Number 3 example. And again, I repeat, you only need to write down 4 for your notes. First, what's the order of operations?
The parentheses.
You do
first.
what's in parentheses first, right?
You'd have to do the multiplication with.
Or
it
you
first.
could distribute, right?
Yeah.
You could do either, because we've learned distributive properties since that, but I would take care of what's inside the parentheses first. So follow the order of operations. So inside the parentheses,
You can change tangent to sine over cosine.
okay, then what would I do? Okay, well, let's do inside the parentheses first. Don't we have to multiply before we can add?
Yeah.
So when I multiply this, don't I get sine squared over cosine?
Yeah.
Sine times sine is sine squared over cosine. Oh, I forgot to close it. Now, how do I add this?
You can do the butterfly.
We can do the butterfly, which means I put cosine over 1. Does everybody follow that with the cosine over 1? So what's the first wing of my butterfly gonna be?
Cosine squared.
Cosine squared. What's the second wing of my butterfly? Sine squared. And on the bottom, what's 1 times cosine? Yeah, does anybody see anything?
I see 1.
I see 1 too. Why do you see 1, Richard?
Cosine squared of x plus sine squared of x.
Is 1. Does everybody see that? That's 1. Now, I have had students that distributed and then they eventually get there, but it took them a little longer. So sometimes the process could be quicker if you pay attention to your rules. Now, what do I have?
Sine over 1 over cosine. And then so you can we sine over cosine, which would be tangent.
Okay, that's just one way. Remember I said there's multiple ways this could be done. I've had people or students that would distribute first.
Couldn't you take sine times secant if 1 over cosine is secant over that?
Well, yeah, but then you'd have 2 trigs left, right? So it's best if you change to sines and cosines so you can get down to just 1 trig. Now, there's some rare occasions where you can't get in terms of just 1, but most of the time you're going to be able to. Okay, number 4. Well, this one I think is short and sweet and to the point. Right there I can do it. What can I do for tangent divided by sine? What's tangent going to change to?
Sine over cosine, but you could also put sine to the side as well. By switching over.
Invert and multiply?
Yeah.
Okay, well I think that's what I'm going to do next. So that says tangent sine over cosine, and I'm dividing by sine. What do you do when you divide with fractions?
Multiply it by the reciprocal.
Invert and multiply. So that would be 1 over sine. Now what happens?
Cross multiply.
Sines cancel out, so I'm left with 1 over cosine, which is secant. Okay, number 5. Many ways to do this one. Many ways. Anybody see anything they want to do first?
Cosecant squared on top, right?
One.
Yeah. 1 plus cotangent squared is cosecant squared. Does everybody recognize that?
What?
1 plus cotangent squared is
Oh,
cosecant
okay.
squared. So I can change this to cosecant squared. Then what happens?
Cosecant over secant.
This will cancel one of these out, so I'll be left with cosecant over secant. Now what can I do? What's another way of saying cosecant?
1 over sine.
1 over sine. What's another way of saying secant?
1 over cosine.
And isn't this mean divide? And what do you do when you divide with fractions?
Multiply by the
Invert, multiply. You flip the bottom and multiply, right? So what do we end up with?
cotangent.
Which is cotangent. Which Mason saw the shortest way to get the problem done, but I have had students that changed this to 1 over 1 and cotangent to cosine squared over sine squared. And what do you think they did? They changed everything to sines and cosines first. I'm not saying, I'm just showing you another alternative to show you there's other ways to do this. So then I'd butterfly, right?
And that's a lot more.
It will be sine squared plus cosine squared over sine squared. When I divide, I invert and multiply, so this would be sine of x, cosine of x over 1. Does everybody agree with that? And what do I know sine squared plus cosine squared is?
1.
1. That's the one I expect everybody to say just like that. That's the one you better know. So So it's 1 over sine times sine over cosine, or sine cosine, so that does cancel. Did we get something different? Oh, yeah, I see why. I forgot to write down what this was over, it was over sine squared. So I should have a sine left on the bottom, right?
Mm-hmm.
So that would be cosine over sine, which is,
Cotangent.
so we got the same thing, just did another way. So there's multiple ways you can simplify these. Ready for number 6? I think I'll write these down. Okay. Who has such a suggestion?
1 minus cosine squared of x from the sine squared of x, right?
Correct? What could I do with secant squared? Put it over 1 over cosine. Okay. So now don't I get sine squared over cosine squared? Which is tangent squared. Everybody good there?
Do the powers not reduce?
No, powers won't reduce, because if I can cancel, like if I had a sine down below and a sine squared, then I can reduce, but the powers stay with it. So number 6 is done. What about number 7? Does anybody see anything we can do?
You do the reciprocal cotangent.
Okay, so that would be,
Or.
do you wanna make it cosine over sine, or you wanna make
Yeah.
cosine over sine?
Yeah. Cosine over sine.
So this would be cosine squared over 1 divided by cosine squared over sine.
Yes.
Does everybody see what I did there? I just changed cotangent to that, and this line meets the divide. So what do I do when I divide?
You can multiply by the reciprocal, which means sine squared x over cosine squared x.
And you have to multiply before you can subtract.
And then the cosines can cancel.
So I'm left with 1 minus sine squared, which is
Cosine squared.
cosine squared. Everybody with us? That's just one way to do it, right? I said there's multiple ways you can get there. What about the 8th one? I want everybody looking at that one. It's already in terms of sines and cosines.
Didn't you make cosine to the 4th cosine squared times cosine squared?
You could. I could also make sine to the 4th sine squared times sine squared,
Yeah.
which that ought to tell you there's something we can do to it.
Use
No.
powers.
Let me give you a hint.
Yeah, if you were to do that, that would be.
Can't I factor it? Isn't that a trinomial? Didn't I say all skills of math is gonna be involved?
Right.
Yeah.
So what times what gives you sine to the 4th?
Sine squared times sine squared.
What times what gives you cosine to the 4th?
Cosine squared times cosine squared.
Last term's positive, so you take sine in the middle for both.
But what about the 2 in front of
Doesn't that give me 2 when I do FOIL? First times first,
Oh,
outer
yeah.
and inner, doesn't that give me 2 sine squared cosine squared?
Yeah.
Last times last?
Mhm.
So is that right? Now, what is it? What's sine squared plus cosine squared?
1.
1's my answer.
Surprise.
So I'm showing again that you can have a numerical answer. Okay, so you can end up with a trig answer, or you can get a numerical answer, if everything simplifies nicely out. Everybody follow what we're doing?
Mhm.
Okay. Now we can shut off the video,
Was that
and
the quickest way?
that was probably the quickest. That was pretty quick.
Yeah, well, I did definitely.